This is the current headlight setup on my Jetson Bolt Pro, which uses a separate 9-volt battery for power. I've grown to prefer the separate battery for the headlight, but was curious about how to power it with this eBike's 36-volt battery. I'll show you what I find next. When I replaced the original headlight with this DIY one, I left the existing wiring within, but not in use. Once I get this front section of the headlight off, the unused wiring will be just inside. It can still be powered on with the throttle side button and provides 40 volts. Whether I use the unused wire within the headlight or tap directly into my eBike's 36-volt battery, I'll have to convert either power source to match the 9 volts of my current headlight. I'll do that by using these DC to DC converters. The larger one can convert anything between 36 and 72 volts down to 12 volts. The smaller one converts 12 volts to 9 volts. In looking over the 40-volt wire from the previous headlight, I'm realizing the wire is too thin to power my existing headlight. At some point, it'll probably overheat and melt, which could cause some dangerous problems with the battery also overheating. I guess I'll have to instead tap directly into the battery wiring. I'm going to need this XT60 splitter to tap into the battery. I've already ordered it, but it looks like it'll take a couple of weeks for delivery. I may do some work off camera once I receive it, but I'll resume this video once I know how everything will hook up. I don't have the XT60 connector yet, but other than that, what you see here is how all the parts should connect together. I want to do a preliminary test to confirm that connecting everything as shown here will work, but I also want to confirm that no part of this lighting system will overheat, especially the wires. Here's the mock lighting system I've constructed to test all the parts in a controlled environment. By plugging and unplugging the light within 3-second intervals, I can also change the strength of the light so it will draw more power from the battery. While I leave the light powered on at the high setting, I can check the wires and components for heat. There's 5 different brightness modes the light will cycle through whenever I power off, then on again within 3 seconds. The modes are something like 5%, 15%, 25%, 50%, and 100%. I'll test 100% for overheating, but if the wires don't begin to heat up within a few minutes, I'll change modes because at 100%, the light itself has an overheating safety mechanism that will turn off the light before it gets too hot. Using the same mock lighting system, I fitted into my battery compartment with everything else that also belonged in there. This was still for test fitting purposes and not meant to be permanent. I ran the 9-volt wire under the down tube and into the headlight battery compartment, but removed that battery. The purpose was to pass the circuit through the on-off switch, so I'd now have a way to control the headlight. I was surprised at how well this setup worked. If I were to drill a 5/8" hole in the main battery compartment, run the 9-volt lead through that hole and into the headlight battery compartment, that could easily make this into the permanent setup. Considering this system will convert a power source range of 36 volts through 72 volts into 9 volts, makes it possible to use different batteries or move this system easily from e-bike to e-bike. I'm very impressed with how well this headlight adapter turned out. I still need the splitter cable that hasn't arrived yet, but that'll be easy to swap out with the wiring at the end of the 36-volt converter. At this time, I still prefer a separate battery to power my headlight, but it was nice to discover another way to rig up the same headlight in a way that could be useful to others. I hope this video can provide you with some knowledge that could be useful for your custom headlight setup. Leave any questions or comments you may have in the comment section down below. That's all I have for now, and I'll catch you in the next video.